We are going to look at Group 1 as an example of the pattern you can see in the periodic table. Group 1 contains the elements lithium, sodium, potassium, rubidium, cesium and francium. If you draw out their electronic structure, the first thing you notice is they all have one electron in their outer shell. The other thing to see is the number of shells they have is related to the row they're in the periodic table. For example, sodium has 3, so this therefore is their period. The elements in the group are all metals. They are all soft metals which can be easily cut. They get softer as you go down the group. Not that you would be wise to try and cut rubidium and cesium. All of the elements are stored in containers that either have paraffin or inert gases in. This is because of their reactivity. All the metals will react with air readily. They tarnish quickly in air, reacting quicker as you go down the group. Their reaction with water is violent and shows the same trend. Why is this? 2 reasons. Firstly, the outer electron they have is easily lost. Secondly, as the atom gets bigger, they find it increasingly easy to lose the electron. This is why cesium is the most reactive metal we know. The reason for this is the outer electron is a long way away from the nucleus and therefore is easily picked off. But also, the electrons in the other shells interfere and stop the nucleus holding on to the electron. This concept is known as shielding. This acts a bit like wrapping a magnet in paper and imagining that you're trying to use it to pick up nails. The more paper there is, the less nails the magnet will attract.